Pulleys with Mel and Belle. Yeah!
So for our first problem, we have two masses, M1 and M2, and they are hanging from a massless string from a frictionless pulley. If M1 has a greater mass than M2, determine the acceleration of the two masses when released from rest. So our first step is going to be to identify a direction as positive. Since when it is released from rest, the pulley will accelerate downwards towards M1 because it has a greater mass, we will make the direction of M1 positive. Next, we have to create our free body diagrams according to our new positive direction. Our free body diagram for M1 will be flipped around compared to M2 because of our choice in positive direction. After, we will set up our equations using Newton's second law, which is the sum of our forces is equal to mass times acceleration. For the first mass, we have m1g, or the weight, minus tension, equals m1 times acceleration. Our second mass is tension minus m2g is equal to mass times acceleration. We will solve for t and then substitute it into the other equation in order to solve for acceleration. When we solve for t, we end up with m2g plus m2a. Now we have to plug that into our first equation. So now we have m1g minus our new tension is equal to m1a. We have to distribute. And next, in order to combine like terms, we move over m2a to the right side. We factor out the g on the left and the a on the right. And in order to solve for a, we must divide both sides by m1 plus m2. Our acceleration is equal to the force of gravity times m1 minus n2 divided by m1 plus m2. Our next problem includes a pulley that's suspended off the table and asks us to find the acceleration of block A. First, we draw our free body diagrams and see that block A has a force of friction exerted on it, which is equal to 5 newtons. Since the tension is the same all along the string, we know that the tensions from both free body diagrams are equal to each other, and can therefore redraw the diagram for block A. Basically, the rope is redirecting the weight of block B from right to down. So if we redraw it, we can redraw the rightward force acting on block A as the weight of B. We can then solve for B using the formula for weight. Next, we use Newton's second law to distribute the forces on block A. Since it is not moving vertically, we know that the F of y is equal to 0. So our total force along the x-axis is equal to the total mass of both A and B times acceleration. We can then substitute in 10 kilograms for block A and 2 kilograms for block B. And using the free body diagram of block A for reference, this all equals to the weight of B minus friction, which was equal to 5 newtons. We can then divide both sides by 12 kilograms, or the total mass, and solve for acceleration. Our acceleration is equal to 1.22 meters per second squared.
Next, we will be finding the magnitude of the acceleration of the entire system. This will equal the net external force divided by the total mass. This only works if they move with the same magnitude. To understand, an external force is a force that exerts on an object from outside the system that causes the system to either go or prevent it from going. One main external force is the force of gravity that is put upon the blocks. Since the 3 kilogram block drives down the entire system, this can be a positive force. And the 2 kilogram block is negative since it goes opposite the force of motion. Acceleration equals 3 kilograms times gravity minus 2 kilograms times gravity over the total mass, which is 3 kilograms plus 2 kilograms, which is 5 kilograms in total. So if we were to add this up, acceleration would equal 1.96 meters per second squared for the entire system. Now for tension in the rope, all I will use is Newton's second law. And all I need to look at is one of the masses, since tension is the same throughout the rope. So acceleration of the 3 kilogram box equals the net force of the 3 kilogram box over the 3 kilogram mass. So we already know acceleration is 1.96 meters per second squared. But since we're using Newton's second law, it's going to be negative 1.96 meters per second squared, since it's going in a negative direction. Now, the net forces of the 3 kilogram is tension minus the weight of the box. So tension minus 3 kilograms times gravity divided by the mass. Now after this, you're going to solve for t by moving all the variables to the other side. When adding everything up, you should get 23.52 newtons equals t for the 3 kilogram box. But remember, this should be the same tension throughout the entire rope.
What time is it? It's pulley time!
Thanks for watching Pulleys with Mel and Val. See you soon.